Ready to dive into something huge. We're talking predicting the structure of proteins. Like crazy accurate. Just a few years ago, this was basically sci-fi.
It really was.
Imagine, though, designing new medicines, super efficient enzymes, even custom-built biomaterials, all because we understand these, what are they, microscopic machines, the things that make life work.
It is becoming reality. It's not just theory anymore. Today, we are going a deep dive into the game-changing work of AlphaFold.
Okay.
This system is taking a swing at a 50-year-old challenge in biology,
The
protein folding problem.
I am so ready. Now, I know our listeners, they know their stuff, but just a quick reminder, why has protein folding been such a puzzle? And why should we even care?
You should care because a protein's shape is everything. It dictates what it does. So you've got this long chain building blocks, right? Amino acids, they're all linked together. Imagine beads on a string. Simple enough. But that string, it doesn't just stay straight. It twists, folds, and coils up into a super complex 3D structure. And how it does that, it's all based on the order of those amino acids. And that shape, that unique shape, that's what tells the protein what to do.
So you're saying if we can crack the code, figure out how a protein folds, then we know what it does, how it interacts.
Yeah.
We can even design totally new proteins, ones that do specific jobs.
Yeah, exactly. But the challenge has always been, well, the possibilities, there are so many. For even a medium-sized protein, the number of potential shapes, it's astronomical. Predicting that with any real accuracy, it's a computational nightmare.
That sounds like a nightmare. Like trying to do a jigsaw puzzle where every single piece fits together a million different ways.
At least a million. And for decades, scientists have been using all sorts of different approaches to try to solve this puzzle.
Yeah.
Some of them, they rely on simulating physics, how atoms interact. They're searching for the most stable configuration.
Right.
Others, they look for clues in evolution. They figure proteins, if they have similar sequences, well, they probably fold into similar shapes.
So like a protein family tree to figure out the structural, like, heritage.
Exactly.
Smart. But those methods, they weren't enough, or we wouldn't be talking about AlphaFold. Right?
Yeah, they had their limits, especially, when you're looking at a novel protein, one that doesn't have clear evolutionary relatives.
Right.
That's where AlphaFold comes in. That's where they're bringing the power of AI.
Okay, yeah, tell me about AlphaFold. What makes it so different? Why is it so revolutionary?
So imagine you're feeding a supercomputer this massive library. It has all the structural blueprints of proteins, tens of thousands of them.
Wow.
And you've got their amino acid sequences all carefully mapped to these intricate pretty forms, right?
Yeah.
That is essentially what the team at Deepmind did. They trained this, well, it's a sophisticated neural network. And they use this massive data set.
Wow. So they're basically giving this computer a crash course in, like, protein origami. You show it enough examples, it figures out the rules of folding.
Yeah, and it's not just memorizing. AlphaFold actually learned. It recognizes patterns, the relationships within the data. It developed almost this intuitive understanding of how the amino acid sequences translate into those protein structures.
But how do you even test that in the real world, if it works?
So there's this thing, CASP, Critical Assessment of Protein Structure Prediction.
Okay.
It's like the Olympics of the protein folding world.
Okay.
Every 2 years, teams all over the globe, they go head-to-head. And they're tasked with predicting the structures of proteins. And these proteins, they've been recently experimentally solved, but not publicly released.
Oh, wow.
So it's a real blind test.
So high stakes. High stakes. Okay, so how did AlphaFold do in the Protein Olympics?
AlphaFold, it didn't just compete, it dominated.
Okay.
In the 2020 CASP14 competition, it got a median accuracy of 0.96 angstroms.
Okay. I have no idea what that means.
So to give you an idea of the scale, that's like the width of a single atom.
Oh, wow.
Imagine like predicting the length of a football field
Okay.
to within the thickness of a dime.
Wow, okay.
That's how precise we're talking.
That's incredible. That's mind-blowing, okay? But it's one thing to be great in a competition,
Right.
in a controlled environment. But what about when you take this to the real world?
Yeah.
With all the complexities of, like, real proteins, does it actually lead to breakthroughs? So AlphaFold is killing it in the lab. But in the real world, does it actually work?
That's what we want to know, right?
Okay.
And it turns out, yeah, it does. So they took AlphaFold and tested it on this huge data set. All these brand new protein structures, ones that had never even seen before. And get this, it still made these like crazy accurate predictions.
Oh, wait. So it's not just memorizing.
No, it's like it actually learned AlphaFold learned how to speak protein. Like, it knows the language of protein folding.
That's amazing. Okay, so it's one thing to see the results.
Right.
But what's even cooler is that scientists can now actually look at how AlphaFold works. Like how it gets to those predictions.
It's true. By analyzing those intermediate steps, it's like researchers are getting this like behind the scenes look. It's like watching one of those time-lapse videos.
Yeah.
Where you see like a complex origami creation come together.
Yeah.
You can see how each fold influences the next one.
Right.
And it reveals this elegant logic behind that final structure. It's like that with AlphaFold. You're watching this protein shape emerge from this linear chain of amino acids.
I love that. That's such a cool visual. Okay, but even with all of this, I mean, AlphaFold's got to have some limitations.
Yeah.
Like, what are we missing here?
Well, of course, it's like any tool, even a really powerful one. There are going to be strengths and weaknesses.
Right.
One thing it really needs, a lot of evolutionary information. Remember those MSAs?
Yeah.
The multiple sequence alignments?
Yeah, the protein family trees.
Yeah, exactly. The more branches, the more relatives that AlphaFold has to compare, the better it's going to be. It's going to be more accurate.
So it's like, if there aren't that many relatives to look at, it's harder to figure out where that one protein fits in.
Exactly. And there are other things that AlphaFold struggles with a bit, like predicting the structure of proteins that really rely on interacting with other proteins.
Because proteins, they're social. They don't just hang out by themselves.
Exactly. They team up.
Yeah.
They form these really complex partnerships and assemblies and
Right.
all those interactions. Well, they can really change their shapes.
So even though AlphaFold is a huge step forward, there's still a lot about proteins we need to figure out.
Absolutely.
Okay, but zooming out for a second, this might be a big question, but why should people care? I mean, if you're not a scientist working in a lab every day, why does any of this matter?
The potential is just massive. We're already using AlphaFold to like map out the structures of almost every protein in the human body.
Wow.
And this is like a treasure chest of information. This could totally change medicine, change drug discovery. Imagine if we could just design drugs that go straight to the source.
Yeah.
To the proteins that are causing the problems. Or what if we could even create brand new proteins, ones that can, I don't know, clean up pollution
Yeah.
or help with manufacturing. The possibilities are really pretty exciting.
It really feels like we're on the edge of something huge. So as we wrap up this deep dive, what's like the one thing you really want our listeners to remember? What's the big takeaway about AlphaFold?
I think it's that AlphaFold is giving us this totally new way to see the world, or at least see the building blocks of life. It lets us look at these proteins with a level of detail that, honestly, we never thought possible. It's like we're entering this whole new era of protein science, and who knows what we'll discover next.
It really feels like a new frontier. Thank you so much for joining us on this amazing deep dive into AlphaFold. The future of, well, everything is looking pretty exciting.